Hi guys, my name is Ria, and today we're going to be talking about 3D bioprinting. First off, 3D printing is layer by layer additive manufacturing to obtain a physical result. You may wonder why 3D bioprinting is specifically important. Recent data shows that the need for organ transplants is rapidly increasing. With an unproportional amount of donors and those on the transplant list, the need for another solution is vital, and 3D bioprinting just might be it. So why is 3D bioprinting so different from regular 3D printing? With bioprinting, the product will be used in the human body and is required to sustain itself within it. Therefore, extra caution must be taken with material selection, 3D printing method, and applications. Organs are complex in nature and require the use of different hydrogels and cells to compose each layer. Because of their complexity, 3D bioprinting can be very hard to accomplish and requires detailed steps. In order to understand the overall concept of 3D bioprinting, I will explain a four-step process. Here it is: imaging, design approach, material and cell selection, and finally, bioprinting. To start off, we need a clear image of what we are trying to replicate. Usually we use an X-ray, CT scan, or MRI to obtain this image for printing. The image is converted to a model in order to technologically break the organ up into individual layers so that it can be replicated. Material and cell selection is the most important step because the object will end up inside a human body. Therefore, the materials have to be non-toxic, unable to swell due to oxidation, and biodegradable. Since hydrogels are usually liquid at room temperature, there needs to be a chemical process that solidifies them. There are two processes that do this. Cross-linking forms covalent bonds between polymer chains to join them together. This process transforms viscous hydrogels into solid materials. The photoinitiator process rapidly cross-links a material through the exposure of ultraviolet light. While selecting materials, one has to choose whether to use cells while printing or use them after, and therefore create a scaffold. A scaffold is a mold of an object that will later have cells added to it after the 3D printing is complete. There are three types of techniques in bioprinting. Inkjet dispenses the materials drop by drop. Microextrusion releases the substances through a syringe, and laser-assisted uses a light projector to solidify hydrogels correctly to form shapes. The organ is then transplanted into the human body. There will be many future advancements with 3D bioprinting so we can have more organs to provide to those who need them. Thanks for learning with me.